Hello, this is Mr. Collier, and today we are simplifying surds. Okay, so some people call these radicals, but surds are just numbers or expressions with a square root sign, or possibly even a cube root sign in some instances. Okay, so let's take a look at some simple surds first of all. Some like square root of 49 is what number times itself gives you 49 is obviously 7. Okay, it's useful to know the square numbers, like 1 squared is 1, 2 squared is 4, 3 squared is 9. These are the square numbers, perfect square numbers, and they're kind of useful to know. And they go on and on and on. Let's check out this next one here. We have the numerator and denominator are both square numbers in this list. So the square root of 9 is 3 and the square root of 16 is 4. So this is 3/4. And you can check your answer pretty easily. 3/4 times 3/4 is 9/16. So it is correct. Here you cannot square root the 8. So, but you can simplify the fraction because the numerator and denominator, you can divide them by 2. And then you get 4 out of 25, and now all of a sudden we can square root the fraction. This is going to be 2 over 5, right? 2/5 times 2/5 is 4/25, which is the same as 8/50, so it's correct. Now, whenever you have a decimal, it's actually a lot easier sometimes to write it as a fraction. So this is root 25 over 100, or just 25 over 100, so it's 5 over 10, or just half. Or you could write 0.25 as a quarter, and you get the same thing, you get half. Okay, so let's look at multiplying and dividing surds. Well, we know root 4, root 9 is going to be 2 times 3, which is 6, and that's the same as root 36 is 6. So you can actually just multiply these two numbers inside the square root sign and get a root 36 is 6. So to write this algebraically, the rule is root A times root B is just simply root AB. And it works similarly with dividing. This is 6 over 2, which is 3, and root 9 is just 3, and that's the same as 36 divided by 4. So we can also say root B over root A equals root B over A, for instance. So we have this rule. There's the perfect square numbers I was mentioning before, and you can simplify surds like this one here. This is root 8. You can write that as root 4 times root 2 using the rule we just talked about above, and root 4, so you need a perfect square factor. Root 4 is a perfect square number, so we can simplify this as 2 root 2. Okay, root 8 and 2 root 2 are exactly the same, they're equivalent. 50, you gotta look at which number goes into 50, and obviously 25 goes into 50. So that's 5 root 2. 60 or 48. You want to look at the numbers that go into 48. 16 goes into 48. And that is 4 root 3. And root 300, well, obviously 100 goes into that. That's root 3 root 100. So that's 10 root 3. And here we have the numerator is 18, so that's root 9 root 2 over 2, and root 9 is 3, so you can write it as 3 over 2 root 2. Okay, let's do a couple more, like root 5 times root 5, well that's just root 25, and it's just like 5, so the surd cancels. Here, you can use our rule we just developed above, and that's root 16, which is 4. Remember, you can just divide these and get root 50 divided by 2 is 25. And that's 5. And now squaring this surd here is just 2 root 2 times 2 root 2 And 2 times 2 is 4, and then root 2 times root 2 is another 2. And so the whole thing is just 8. The next one, you can rewrite this as root 32 over root 2 times 10 over 5. And this is negative root 16 times 2, negative 4 times 2, which is just simply negative 8.